Hello everyone. Today we are going to see how to find the probabilities on normal distribution curve. So first important thing that you should understand when you are using normal distribution is that uh, the curve is a symmetrical curve. So this is how you draw normal distribution curve, and there is a line here which represents mu is equals to 0. So this particular point will divide the graph into two equal halves. And one more important thing is the total area under the graph is equals to 1. Okay, so this part is 0.5 and this part is 0.5 units. So the total area will be equal to 1. Okay, so since the normal distribution uses continuous data, the values you find are going to be in terms of intervals or ranges. So that is how you have to understand and find the find the solutions for the given values in the normal distribution curve. So let us see an example. Okay, now let us find out the first value p of z is equals to 1.54. Let us find out this value. Okay, now this value will represent a range of z which is from 0 to 1.54. So if you every value that you want to find in a normal distribution has to be represented in terms of the curve, normal distribution curve. Okay, now let us draw the curve. This is the normal distribution curve. This is the point where mu is equals to 0, and this part, so left side of the graph is 0.5 units and right the area covered is 0.5 units. So I want to find a value which is 1.54. It will be somewhere here. Okay, now what you want to find is this area. Okay, this z is equals to 1.54 will represent this particular area in the graph. Now how do you find this area? P of z is equals to 1.54 is already given in the graph. Okay, so let us see what is already given in the distribution table. So we have a set of normal distribution values in the tabulated form, which will help us easily find out the values. Otherwise this might take a lot of calculations. So we have pre-calculated values there. So let us find the value. So 1.54, right? So 1.5 is here. So 1.5 is here. And 0.4, so total 1.5 plus 0.4 is 1.54. The common value here, sorry, this is not the common, the common value is 0.4382. okay, so this is equals to 0.4382. 0.4382. okay, so this is how you find. Now let us see another example. Let us find the value p of see, the question is given like this: find the area between, so area between minus 1.2 and 0. okay, so how will you represent this? Is in terms of your p is minus 1.2 less than or equal to z less than or equal to 0. okay, so now if I take this value in a normal distribution curve, okay, so minus 1.2 is somewhere here and this is 0, so you have to find this area. okay, now if you can also change this to the positive axis. How can you do it? You just have to change the inequality. So instead of writing minus 1 minus 1.2 less than or equal to z less than or equal to 0, you can write it as 0 less than or equal to z less than or equal to 1.2. This is how you can change the axis. And now what happens is, instead of this part here, what you will do is you will find the positive axis 1.2, this area. Okay, so how will you find this area? 1.2 is already given. 1.2 in the table, 1.2 in the table is 0.3849. So therefore this is equals to 0.3849. Okay, now let us take a little complicated one. So the example here, okay, yeah, find the area. Another example, find the area to the right of z is equals to 0.25. Okay, now for example, this is the graph. Not for example, you have to draw the graph. This point is 0. 0.25 lies somewhere over here. Okay, now they are asking the area to the right of 0.25. So the area to the right of 0. This is the right side, this area. They are asking for this area. Okay, now this part you know how to find the value of 0 less than or equal to z less than or equal to 0.25. This part you know. This we can find from the distribution table. What is the value of 0.25? 0.2 is here and 0.5 is here. 0.25 is 0.0987. 0.0987. Okay, now this part we know. This part we know, this is 0.0987, but what we want is this part. This we don't know. So how should we solve this problem is, what we initially know is that the total area is equals to 1, right? And this part is 0.5 and this entire part, this part from here, this part is 0.5. Okay, so okay, this total part is 0.5 and we know this part is equals to 0.0987. Okay, so if these values are known, can't you find this part? Becomes easy, right? How? 0.5 0.5, this total area, minus 0.0987 will give us this area. Isn't it easy? So 0.5 minus 0.0987 will give us 0.4013. Easy, right? So this is how you're supposed to find the probability values. Okay, so let us see another example. They're asking us to find the area to the left of 1.96. Left of 1.96. So this is the graph. This is 0. Okay, 1.96 is this. So left of 1.96, they are asking us to find this area. Okay, so now what you do is, we basically know this part is equals to 0.5. You just have to add this part now. Okay, so what is this value? This is 0, p of 0 less than or equal to z less than or equal to 1.96. This is easy to find. You can find it in the distribution table. So what is 1.96? 1.9 is here and 6 is here. So 1.96 is 0.4750. 0.4750. Okay, you already know this part. So 0.5 plus now this part remaining 0.4750 will give us 0.9750. So this is the area between, so this is the total area to the left of 1.96. We are finding the total area like that. Okay, so let us say another example, a little more complication to this. Okay, find the area between 0.6 less than or equal to z less than or equal to 1.8. Okay, now draw the graph. This is the point of assumption, mu is equals to 0. Then area between 0.6 is here and 1.8 is here, assumption. Okay, now they are asking us to find this area, right? Now how do we find this area? What we know is, initially what we know is, we know this part, 0 less than or equal to z less than or equal to 0.6. This value we can find from the table. We can also find p of 0 less than or equal to z less than or equal to 1.8. We can find these two values from the graph. Yes, so let us find the values from the graph. If you look at the graph, you get 0.6. 0.6 is here. This is 0.2257. This is 0.2257. This is 2. Let me write it once again. 2257 and 1.8. 1.8 is 0.4641. This is 0.4641. Okay, now what you do is, from this part, if you subtract this part, yes, you will get the remaining area. Okay, so from this point, that is 0 to 1.8 is 0.4641 minus this part is 0.2257 will give you the area between 0.6 and 1.8. So what is the value? Let me calculate. So this is 0.4641 minus 0.2257 is 0.2384. Okay, so this finding the ranges is simple if you understand the concept of the normal distribution curve. Let us see one more example, last one. So the question is, find the area between 0.4 minus 0.4 and 0.6. Okay, so whatever the question is, first you have to, how will you represent this in terms of probability? Z minus 0.4 less than or equal to z less than or equal to 0.6, right? So how will you represent it in graph now? This is the point where mu is equals to 0. Okay, minus 0.4 is here and 0.6 is here. They're asking us to find this area. So we can divide it into two halves. This is minus 0.4 less than or equal to z less than or equal to 0. Okay, and one more is 0 less than or equal to z less than or equal to 0.6. Isn't it? This half plus this half. Easy. But this is negative value. You change it to positive. So this becomes p of 0 less than or equal to z less than or equal to 0.4. This is as usual same. But what is the value of 0.4 now? In the tabulation, 0.4 is equals to 0.1554. This is equals to 0.1554 and 0.6, and 0.6 is equals to 0.2257. 0.2257. So just add these two values, 0.1554 plus 0.2257, which will be equal to 0.1554 plus 0.2257 will be equal to 0.3811. Okay, so remember what we have done. We have taken this value from the graph and we have taken this value from the graph and just added. So this to represent the minus 0.4 and 6 to be represented in terms of probability is like this. If you have a negative axis, don't be confused, because many times when we have in the graphs, if we use negative values, it tends to be confusing for us. So what you do is you change the inequalities and convert it into a positive value. It doesn't matter, this value is here is going to be same on the both axes. So let me tell you one more thing. 0.4 minus 0.4, this side will have 0.1554 in the table. Even if I have on the positive side, the value will be 0.1554 only, because the nature of the normal distribution curve is symmetrical. So it doesn't matter if you are considering a negative value or a positive value. Negative values are unnecessary in probabilities. Okay, remember that we are just using negative values for the reference for us to calculate the probabilities. That's all. We will continue with next level of problems in normal distribution in the next session. Thank you.